we're going to solve. And the first question is n meeting in one room. So let's understand what this question means. Okay, so actually this problem statement states that there is one meeting room in a firm and you are given two arrays. Okay, start and end, each of size n for an index I, where start of I is the starting time and meeting and end of I is the finish time of the meeting I. Now we have to find what is the maximum number of meetings that can be accommodated in the meeting room when only one meeting can be held in the room meeting in particular. Return the maximum number of meetings that can be held in the meeting room. Okay. So I'll explain you here. Say there is a given array 0, 3, 1, 5, 5, 8, and also there another array that is 5, 4, 2, 9, 7, 9. So what we have to do, we have to just find like how many number of meeting that we can successfully turn in a room. Let's say if you started meeting at 0 and it will end at 5. Okay, so it will be counted as one meeting. Then we will move to 3. Is it possible? No, it is not possible. Why? Because the end point was 5 and we cannot enter 3 as our starting point because 3 is lesser than 5. So we have to check this also. Okay, so this would not be our answer. Now we will go for 1. So 1 is again lesser than 5 and it is in between of 0 to 5. So this is also not our option. Now we will go for 5. Now you will say it is 5, but you can see that this is ending at 5. It doesn't mean you will start again from 5. You have to start it from 6, 7 or so on. Okay, so keep this thing in your mind. You don't have to start it with a lesser number or equals to. You just have to check for the greater number. Fine. And again, now we will come to the next index, the last index, that is 8, 9. Okay, so 8 is greater than 5 and we can start a new meeting in a room. Fine, and we will end it at 9. So these are the two pairs that we found, that is 0, 5. Uh, 0, 5, 8, 9. Okay, so these are the two indexes that is our answer. Let's check. Okay, so there is another question that is 1, 3, 0, 5, 8, 5, 2, 4, 6, and this is the end. So again, you will do the same thing. So this is a brute approach that you can do. You can check for it. Okay, so let's again start. Like initial thought process, what would be your initial process? It could be like, say if you have two meetings and one which gets over early and another which gets over late, which one should we choose? If our meeting lasts longer than the room stays occupied and we lose our time. On the other hand, if we choose a meeting that finishes early, we can accommodate more meetings. Okay, hence we should choose meetings that end early and utilize the remaining time for more meetings. So what could be the approach for this question? See, if we go like 1 by 1, 0, 3, 1, 5, 8, then we are only able to find two set of answers. Okay, but we are using greedy approach. So we need to be greedy sometimes. Okay, we are not satisfied with these two answers. We have more. We need more meeting in a room. Okay, so how we will do? We will first check it from 1, the lesser one. Okay, or you can sort it. It's up to you what approach you are going to use, but it is the easiest approach that I am telling you is that first pick up the shortest one. Let's say, okay, you can say you can also pick up 0, but see the endpoint is the highest. So you don't have to go for it. You just have to check the least endpoint, that is 2. And what's the starting point? It is 1. So it is our answer, 1 and 2. We mark it as 1 and 2. Okay, at index 3. Now we will go for 4. Okay, so 4 is greater than 2. The recent greater than 2. Okay, so this could be our next answer, that is 3, 4, 3, 4. Again, we will go for 7, that is 5, 7, and then 8, 9. That's how we can find our answers. Okay, this is it. And also make sure if you are using greedy approach, then your time complexity will be n log n. Not all of the cases, but in most of the cases. Okay, and this is what I have explained you, and this is the code I'll show you. This is it. You can use pair for pairing up. Okay. Now we will initializing a for loop in which we will be putting endpoints and start points as I have shown you here, like these. Okay. Then you will sort on what basis you have to sort. Like the endpoint should be the minimum, and then it goes to the maximum. Fine. Then you will take three variables, I, J, and answer for storing and for increment or decrement. Okay, could be of any purpose. Now you will be initializing a while loop, that is I should be less than n and J should be less than n also. Now we will again initialize a while loop in which J is less than n and a of I dot second. That dot second means the value. Okay, that should be lesser than or equals to a of I dot first. That means the starting point. Okay. Now, if this condition satisfies, we will do answer plus plus and J is equals to I, and then we will return our answer. Yes, it is working. Okay. So this was very easy problem. N meetings in a room. I hope you are clear with it. Like you just have to find how many maximum meetings you can assign in a room according to the starting point and the ending point. You just have to sort the ending point. Okay, that would be very clear to you and you can easily do it. Now, our next question, that is minimum number of platforms required for a railway. Just give me 1 minute. Required for a railway. What does this question say? So I'll brief you. We are given two arrays, okay, that represent the arrival and the departure times of the trains that stop at a platform. Okay, we need to find the minimum number of platforms needed at the railway station so that no train has to wait. Check our first input, that is, let's say there are n means number of elements in an array, that is 6. And array 1 is, this is the time when train comes at this station, and this is the departure time, that means the train goes by. Okay, and the output is 3. How 3? Like you just have to find how many numbers we are like how many railway stations or platforms do we really need in a railway station for these trains departure or starting time. Okay, so there are at most 3 trains, as you can see at the time. Now how we had done this, let's check this out. So let's say this is the starting time of a train. Okay, at 900 here the train comes, and at 9:20 it departs. Okay, at 9:45 it comes, 1200 it goes, 9:55 and 11:30 it is actually it is 11 o'clock, it is 11:50. So if the train comes at 9 a.m. and it goes at 9:20, so one platform is needed for this train. Now the second train that comes at 9:45 and goes at and departures at 12. So another platform we need. Why? Because at 9:20 it was no, we don't need another platform for this. We can use the first one's platform, because 9:45 you can simply just it is a trick, or you can understand for this question, that is, if this time is lesser than this time, so we can combine this time into its platform. Okay, let's say train 1 needs a platform that is coming at 9 o'clock and we departing at 9:20. Okay, so first platform was needed for this train. Now at 9:20 the train has been departed. Okay, so at 9:45 another train comes and it will go at 12 o'clock, whatever it is, PM or AM. So we don't need any other platform for the same. We will combine this train in first one's platform. Okay, so up till here we only need one platform. Okay, now we will check for 9:55. 9:55, it is the value in between 9:45 and 12. So we cannot just combine these two platforms. We have to have another platform for this train. So we will be taking another platform that counts 2. Now from index 0 to 2 we need 2 platforms. Okay, I guess it's clear. Now at 11 to 11:50 again we need another platform. Why? Because it was leaving at 12. So we need another platform. Now the number of platforms are 3. Now the train comes at 15 and 1900 and 19 and 40. Yes, 19. It will depart at 19. So 15, it is, as you can see, it is greater than all of these values. So we do not need any of the platform. We can start again from platform 1. Okay, so this train needs first platform. Now from 1800 to 2000, we don't need another platform. We can just combine this platform in it. So the maximum number of platforms that you have seen are 3. Okay. So you just have to check these values, the departure value and the starting value, the starting point at which the train is arriving. Okay, so you just have to check this. Now we will understand the code. I hope it is clear. I will again explain the intuition, what this question says. Let's say take each interval of arrival and departure one by one. Okay, and count the number of overlapping time intervals. This can be easily be done using nested for loops, as you can see. Okay, no, here we don't have nested for loops. Now maintain the maximum value of the count during the process and return the maximum value at the end. So what would be the approach? We need to run 2 nested loops, or we can only run a while loop. That would be fine inside the inner loop, and count the number of intervals which intersect with the interval represented by the outer loop. As soon as the inner loop ends, just update the maximum value of the count and proceed with the next iteration of the outer loop. After the process ends, we will get the maximum value of the count. Okay, and you can use this approach as well, where you will sort the array time and the departure time. That would be very easy for you. And we will take a platform needed, a result, I and j variables, and we will be using a while loop. So from I should be less than n and I should be less than. Okay. फिर उसके बाद क्या करना है? If we have to use if condition, that will show if array of I, that means this variable, is less than this, then we will increment the platform needed variable and I. And if it is not, we will decrease the platform needed and we will increase j. Okay, if platform needed is greater than the result, so we will put the value of the platform needed in the result and we will return the result. Okay. It is working. Now our third question is job sequencing problem. Yeah, its time complexity was n log n. Again, question is job sequencing. Problem statement states you are given a set of n jobs where each job comes with a deadline and a profit. Okay, the profit can only be earned upon completing the job within its deadline. So what we have to do, we have to find the number of jobs done and the maximum profit that can be obtained. Each job takes a single unit of time and only one job can perform at a time. I hope it is clear. And this is the deadline and it is a profit. Let's say you have started at 1 and the deadline is 4. So how many things you have covered? 1, 2, 3, 4. Now the idea is 2 and deadline is 1. You can't take these 2, 1, 3, 1, 4, 1 by because you have the deadline 4 and you have already used it. So the profit would be 40 only. But we are greedy. So we don't need this approach. We have to think something out of the box. And that is, we will use greedy approach. Okay. We don't have to think that much out of the box. So what we can do, instead of taking 1 and 4 at once, we can take 2, 1, 3, 1, 4, 1. Okay. And we will find, let's say these 3 have the same deadline. So we will check the profit. If the maximum profit, that is 40. Okay. So we will take this third ID with a deadline of 1 and 40 as the profit. Now we will check the another deadline that is greater than 1. So we can't see 2 or 3 here. We can see 4. We will take this ID that is 1 and where its deadline is 4 and the profit is 40. And we will add the profits of ID 3 and ID 1, that is equals to 680. And this is our maximum profit by greedy approach. Okay, so this is another example. Let's say the deadline is 26665 4, 2, 4. So you just have to check for 2. Okay, you can see many 2 here, but you first you have to check the deadline. You can also use this brute approach as you will sort the deadline and will check for the profit. Let's say there are 1, 2, 3, 3, 2 as the deadline. So which ID we will be taking? We will be taking that ID that has the maximum profit. So ID 6 has the maximum profit with a deadline of 2. So we will take this mark 2 as 6 and then 2 is done. Then we will go for 4, that is 20. And then we will go for 5, that is 60. Then 6, that is 70. And we will add it and we'll get the sum. Okay. So again, I will be explaining you the approach. The strategy to maximize the profit should be to pick up the jobs that offer highest profits. Okay. Hence, we should sort the jobs in descending order or profit. Now, say if a job has a deadline of 4, we can perform it any time between 1 to 4, as we have seen. Okay, any time between 1 to 4. But it is preferable to perform the job on its last day. Okay, you can't say that I will perform it at first day or second day. You can perform it at fourth day as well. So that is what greedy approach teaches us. Wait for the last thing. Okay, so you will get these 1 as well and more the profit. So approach says you just have to sort the jobs in descending order of profit. If the maximum deadline is X, make an array of the size X. Each array index is set to initially and has no jobs have been performed yet. Okay, so for every job, check if it can be performed on its last day. If possible, mark that index with a job ID and add the profit to our answer. If not possible, loop through the previous indexes until empty slot is found. So this is what I have told you. You can just use this comparator. And now the array is given as ARR and N is the size of this array. We will first sort it. Okay, then we will take maximum, first index of an array, first element of an array. Okay, now we will use a for loop in this and we will find the maximum out of this and we will find the result and again a for loop and then nested for loop and then that's how you will get your answer. Time complexity of O of log n, n log n. Now our next question is fractional knapsack. I guess many of you guys have done these questions. Okay, so this is the question that we all know. Fractional knapsack problem, which uses greedy approach, a very famous question of greedy approach. So what does this problem state? The weight of n items and their corresponding values are given. We have to put these items in a knapsack of weight W such that the total value obtained is maximized. Okay, we can either take the item as a whole or break it into smaller units. That is up to you. So what is the approach? First, we will be understanding the approach. The greedy method to maximize our answer will be to pick up the items with the higher value. You have to pick up the items with the higher value. Since it is possible to break the items as well. Let's say if you have left with 60 and 10, so you can break it as well. Okay, because it is a fractional knapsack. It is not 0, 1. In 0, 1, you will take either the whole or no one. But in the fractional, you can take the fraction part of the weight as well. Okay, to achieve this, items should be sorted in decreasing order with respect to their value or weight. Once the items are sorted, we can iterate. Pick up the items with weight lesser than or equal to the current capacity of the knapsack. In the end, if the weight of the items becomes more than what we can carry, break the items into smaller units, okay, and then calculate its value according to our current capacity and add this value to our answer. Let's understand with an example. Let's say n is 4 here and weight is 90. Okay, and the values are 100, 60, 100, and 200. So the value or the weight of item 1 is 120 equals to 5. For item 2, it is 60, 10. For item 3, it is 150. Item 4, it is 250. Now what we will do? We will sort them in decreasing order of weight we have. Okay. If we simply check, no, let's simply check by the brute approach. So what you will do first? You will check this. Okay, you will put 100 and 20. So 20 is the weight. You have added 20 here. And then you will go for the second, that is 60, 10. And then you added 10 in 20, that becomes 30. And 90 minus 30, that is 60. So we are left with 60. 150, again 10 is left. So what we will do? For 10, we will do the fractional part of 200. Okay, 200 profit, we will do the 10th part of 200 and we will get as 40. So this is the first approach, but in this approach, we are not getting the maximum profit. Okay, for the maximum profit, you just have to sort them in decreasing order of weight. Okay, so what is the weight? You have to sort it in the decreasing order. So let's say you have taken 250 at first, and then 150 at second, and then 120, then 60 and 10. And if you have decreased these, what you will get first? You will get 50. Okay, 90 minus 50, that is 40. And the profit is 200. You are left with 40. So the next was 150. Can you take 50? No, you cannot, because you are left with 40 weight only. So you will move to the next, that is 120. Yes, you can take 20 weight because 20 is lesser than 40. So 20 minus 40, it becomes again 20. So we are left with this. So here we will use 10 and the profit would be 60, 360. If we take this index 4, index 2 and index 1. Okay, now we are left with 10 weight, 10 units weight as well. So for that 10 unit, we will take this index, that is 100, 50. And we will, for that 10 unit, we will divide this 100 by 50 into 10 and we will get our answer. Okay, so this is it. And we get our maximum answer, that is 380. I hope it is clear. Here as well, this is 60, 100, 120, and the weights are 10 for the 60 and 120. It is already sorted, so you don't need to sort it, but you have to use it because you don't know the other inputs and outputs as well. Another test cases, you have to check for every test case and the base as well. So this is the code vector. Okay, and then we will using a for loop in which we will initialize I from 0 to n and increment it. And we will take double because the output could be, more in value. So it's better to choose double instead of int or float. Okay, so you take double and x is equals to same thing I have told you. Then you will push back these values in the vector that we have taken, and then you will sort the array in the decreasing. Now you will say why we have used this greater, because we have to sort the array in the decreasing order. Okay, then we will take another variable that is as s and double as answer, and then again we will use a for loop in which I would be starting from 0 to the vector size, and you will apply this if and else. If what are we doing here? We are doing this s, that the variable we have taken, and adding it with the array of b of I dot second. That means the value, okay, of the weight should be, if it is less than the weight, the actual weight that is given. So what we will do, we will add this in the answer and we will add this in the s as well. Else, what we will do, we'll add it only in the answer and we will take it and we will return the answer. That's how we will get our answer. Yes, it is working. Now the next question is coin change or find the minimum number of coins. Okay, so you have to given, I will explain you. In a given value v, if we want to make a change for v rupees, okay, these are the rupees. If we want to change the v rupees, we have an infinite supply of each of the denominators in Indian currency. That is, we have an infinite supply of 1, 2, 5, 10, 20, 50, 100, 500, and 1000 value coins and notes. Now, what we have to find is what is the minimum number of coins and or notes needed to make the change. Okay, so minimum of number of coins you have to find needed to make the change. So let's see. Let's understand this question. These are the coins that are 1, 2, 5, 10, 20, 50, 100, 500, 1000. And this is the value, that is 87. Okay, by using these coins, you have to make this. Take this value as your target, that is 87. And anyhow, you have to achieve this target. Okay, so what we will do? First, we will check these elements. If it always should be lesser than or equals to this number. So we will check for 1000. Is it? No, it is not. Now we will go for 500. Is 500 lesser than 87? It is not. Again, we will go for 100. It is. It is also not. Then we will go for 50. Yes, it is. 50 is lesser than 87. So we will add this 50 in an array or in a vector. Okay. Now we will list this or subtract this. What we will get? We will get 37. Okay. Now for 37, we have 20 that is lesser than it. We will add again 20. Then we will subtract it from 37. What we got? 17. Now we will check for 17. That is 10. Yes, 10 is lesser than 17. So what we will do? We will add this 10 in this vector and subtract it from 17. We will get 7. Now for 7, 5. Yes, it is lesser than 7. We will add this 5 in this vector. So what we get? Now only 2 is left. So we will check for this index, that is 2. So what I have told you at first, that the coin should be lesser than or equals to the value given here. And 2 is equals to the value that we got after subtracting it from the index. So we will add this 2 in this vector and we will make a sum of this 50, 20, 10, 5, 7 that is equals to 87. And we got an answer. So how many minimum numbers of coins do we need it? We needed 1, 2, 3, 4, 5. 5 coins we needed. Okay. So it is pretty simple. Now again, you can check for 49 as well. 49, you will go for 1000, no, 500, no, 100, no, 50, no. Now 20, yes, add 20. Also, you can repeatedly choose coins. Okay, it is not like if you have choose 50 at first and then you cannot choose 50 again. You can choose 50 again and again. Okay, so that's not an issue. Now we will add 20 here and we'll subtract it from 49, get 29. Again, we will add 20. We got here and we got 9. Okay, so 9, it is lesser than 10. We cannot choose 10. We will go for 5. Yes, 5 is lesser than 9. So you will add 5 here and you're left with 4. So for 4, you will choose 2. That is 2. Now you can say you will add 1 3 times. Yeah, that is fine. That is totally fine. But keep this thing in your mind that you have to, what's the question is? Question was you have to find a minimum number of coins. Okay, so you cannot just add 149 times. Okay, this is not how you're gonna do. You just have to find the minimum number. So you have to keep this thing in your mind. You cannot add just 1 or 2 or 5, like 100 of time. That would be very lengthy and you cannot get the answer that you are opting for. So you have added 2 times. And if you sum it up, you will get 49 as our answer. You can see here as well. This is the code. Case, if the amount is 0, let's say if the amount is 0, what you will return? You will return nothing. Okay, if the amount is lesser than 0, you will return the minimum number. Okay. This is the recursive approach that I am using right now. And you will take a minimum variable. Then you will initialize a for loop from I initialized from 0 to point size, that is n. or we will increment the I. Then we will take another variable that is answer. And as you all know, we are using the recursion here. So we will take points and amount minus point. Amount minus points is this. This is amount minus points of I means this is the amount and you have subtracted 50 from it. Okay, so what's the answer you get? You have to store 10. This is what it means. Now you have to check for if answer is not equals to the minimum, you will find the minimum again by mini and answer plus 1, and you will return the minimum of it. And this will give you TLE, so you will use TP for it. Okay, and you can use memoization. That is very simple. You just have to initialize DP. Okay, and it is 1D DP, so you can simply just add amount in it, and you have to check the base condition, that is if it is not equals to -1, then return the DP amount. Okay, and in this you just have to add DP here as well as here. Okay, so it is also going to work. And the GFG version of this question is this. Again, here I have used TP. So I guess this was clear. Okay, so our sixth question is assign cookies. Understand? Assume you are an awesome parent and want to give your children some cookies, but you should give each children at most one cookies. Okay, at most, where these conditions come, you just take this condition as the base case, at most one cookies or at most three or what else. Okay, so at most means you can take more than one or more than. Okay, so now each child I has a greed factor of G of I, which is the minimum size of the cookie that the child will be content with. And each cookie J has a size that is S of J. And if S of J is greater than equals to G of I, we can assign the cookie J to the child I, and the child I will be the content. So what you have to do, your maximum goal is to maximize the number of your content children and output the maximum number. Let's understand this question. Let's say you have these numbers as 1, 5, 3, 3, 4, and these are the cookies that are 4, 2, 1, 2, 1. Let's say if you have assigned this first children, fifth children, you cannot find any cookie because it is greater value and there is no value that is greater than or equals to 5. Now for this third one, you can find 3 here, but you are going like 2. So if you assign this 3 with 2, it is cancelled out. Now for this 3, you can assign 1 as well. And for this 4, you can assign 2. You can assign the lesser value, but not the more greater. Okay, in this case, you won't get the answer that you are that you want. Okay, in which case you will get the answer. First, you have to check this greed value, that is 15334. In this question, what you have to think, just have to check this is the file, and can you find any number greater than or equal to 5? No, it is not. So we will just cancel out this 5, that it is of no use. Now we will go for 4. So can you find any 4 here? Yes, you can find. You have found this 4, and we will assign this 4 to 4. Okay, so that would be equal. Now for this 3, can you see any 3 here? Yes, you are. So you assign this 3 to this 3. And for this 3, is there any number 3? No, it is not left. For this 1, you can assign 2 or 1. And for the more profit, you will definitely go for 2. Okay. And how you will solve this question? By taking left pointer and right pointer. This is the first approach, and there are many approaches for solving this question. Okay, so left approach, first you just have to simply sort these arrays. Okay, let's say you have sorted this cookie array that is 1, 1, 2, 2, 3, 4, and you have sorted this children array as well, 1, 3, 3, 4, 5, and you are assigning this 1 with this 1 and this 1 with 3. You can't assign because 3 is greater than this. Okay, so left again move, right again move. That's how you will do. Let's see what variables we have taken. Suppose we have taken the cookie numbers, that is s of size or the vector of size. Okay, then we have checked if the cookie number is equals to 0, then we will return 0. Otherwise, also, okay, otherwise we will return 0. And then the very basic step, that is just have to sort both the arrays, and that would be very easy for you. Okay, then again you will take three variables, that are maximum number and the cookie index, that is cookie numbers minus 1, and the child index, that is this. So the child and these are the cookies. Okay, now you have to check if the cookie index, that is this, if it is greater than equals to 0 and child index is also greater than equals to 0. So you will enter this loop, and what does this loop says? If s of cookie index, that is 1, is greater than equals to the g of this max number plus plus, yes it is. So what we will do, we will increment this max number as 1, and cookie index is minus, and child index also minus 1. Otherwise, if this condition fails, what you have to do, you just have to decrement the child index by 1. Okay, and when we get the answer, we will just simply return the maximum number. It is working. Okay, so this was pretty easy question. Now we will go for our last question, that is subset sums. As the name suggests, subset, you just have to find the subsets. Okay, let's say you are given an array that includes 2 and 3. So what you have to do, you just have to find the subset that could be either 0 or empty, and 2 and 3 and 2 3, so it would be 4. Okay, and then you have to find the sum. Now understand this question. So, and the basic approach that should come into your mind is by using recursion. Actually, it is a recursion question, and those 6 questions were the greedy approach. We have solved with greedy, and this is the recursion question. Okay, so what we have to do using recursion, what would be the intuition? The main idea is that on every index, you have 2 options. Okay, either you select the element to add it in your subset, or not to select the item, that the index, and move to the next index, that is non-pick-up. So first, simply we will understand this. The array is given as 3, 1, 2, and size is 3. So what are the subsets? As you can see, these are the subsets. That is, first is empty, 0, and 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. Okay, and the sum here is empty, that is 0, 3, 3 has its own sum, that is 3 only, 1 is 1, 2 is 2, 3 plus 1 is 4, 3 plus 2 is 5, 1 plus 2 is 3, and adding these 3 is 6. What's the maximum you got? You got 6 here. Okay. This is the recursive approach. Just give me 1 minute. Okay. So this is the approach. What we have to do in this case, we have 2 options. Either we have to pick it up, or we have to drop it out. Okay. You know, this is how recursion works. You just have to traverse through the array, and for each index, solve for 2 arrays. One where you pick up the element, that is, add the element. If you have picked up, you will add the element. Okay, and move to the next element recursively until the base condition arrives. Here, when you reach the end of the array, is the base condition. That means when you reach the end of the array, you will get the base condition. Let's say in this question, you have to pick it up 2, 3, 2, 1, the whole. So what's the sum? That is 3. And then you have taken 3 and 2. What's the sum? 5. And you have not taken, sum is again 3. If you have taken all these 3 numbers, 3, 2, 1, that is 6, and you have not taken, that remains 2. Okay, so this is how we will do. It is very easy actually. You just have to find this forget everything. And first thing that you have to do is find the subsets and find the maximum sum out of it. Okay. That is very naive and basic approach that one could do. So here we go. This is the function. This is the main function, that is vector. Okay, in subset sums, and another vector is array of size n. Then we will initialize a vector that for storing the elements. Okay, for storing the sum. Now we will return 0, int or the index and array and its length and the sum, and we will sort it and we'll return the sum. So now what does this function statement function states? Okay, in this function we have initialized index, sum, vector and its length, and another vector that stores our sum. Okay, if the index is equals to n, that means the size of this array. So what we will do, we will subset sum dot push vec sum. We will add the sum into this vector. Okay, and we will return it. Now, as you know, this is a recursive approach, so we will repeatedly do this for index plus 1, sum plus array of index, and for index plus 1 and sum. Okay. And it is also working. Time complexity is 2 power n. I hope these questions and the approaches are clear to you. If you have any doubt, you can ask me.